Okay. And what I can do is check in Zoom that it's actually.
Are you recording to your computer? Or
No,
to
no,
cloud?
cloud to cloud. So I can check in the cloud whether it's recording.
So I think I recorded everything yesterday. And I've just uploaded the files or they're in the process of uploading and sending it to Elaine, and then she'll forward the link to you as well so that you can download them.
Okay. Yeah, because I think I have got recordings of everything except for the first two talks, mine and yours yesterday. Everything else has been recorded.
Oh, well, no one wants mine.
Yeah, I was going to say you're two, the least important of the day.
I know. I was sat there, I was looking at the next one. I was like, oh, as long as the keynote, you know, from the keynote onwards has been recorded. And
Yeah.
So this looks like it's recording.
Okay, and I just broadcast the message before, so I'll close the breakout rooms if you're ready.
Yeah.
Second countdown.
I'm trying to think, did Eventbrite send out an email?
Yes.
Oh yeah, it did.
I got one this morning.
Yeah.
Okay, I've got one slide to share then.
I can't assign Daniella until she leaves the breakout room.
Oh, yeah, that's all right. They'll come. So many things open.
Just the bunch of people are joining at the moment, so we'll just give it another minute or two.
Oh.
Okay, so welcome back everybody to day 2 of the DataSHIELD conference 2021. Thank you all for your participation yesterday, and I hope that you enjoy today as well. Just to go over quickly, there are a few kind of house rules. The first thing to say is that there are breakout rooms, so please do participate in these. They're going to be active at breaks and at lunchtime, and the links are in the footer bar. And you can go and you can choose one of the rooms to go and chat to participants there, and then you can leave and go to the other rooms, or just have a break and get some lunch and so on as well. During the actual talks, everyone will be muted, and we'd encourage you to ask your questions either by typing in the chat, or better would be to raise your hand using the icons at the end of the talks, and then you will be unmuted and given the opportunity to ask your question. and to participate in the discussion. So the speakers will be kept to time to allow you to have some time to ask questions. And that's really it. So the first talk today, we're very pleased to welcome Professor Harald Binder from the University of Freiburg. And Harald is he has a background in integrative statistical modeling and big data techniques. And he's going to talk to us today about the MIRACUM consortium and how they're using DataSHIELD and machine learning in biomedical research. So Harald, over to you. We're really looking forward to your talk.
Thank you. Thank you for the kind introduction. I'm happy to be here to present what we're doing in MIRACUM. I'll just try to share my screen. Let me see, this looks right. Now I only have to go to full screen. You should see my slides in full screen now.
Yes, perfect. We have your slides and we can hear you loud and clear.
Okay, perfect. I don't seem to have a mouse pointer, but I will do without the mouse pointer. So MIRACUM is one of these acronyms that like at our site we use a lot. So we could even assume everybody has to know this because we use it a lot. No, so the background is in Germany, there's the Medical Informatics Initiative, where the German Ministry of Research realized that there's all these exciting, interesting routine data available at university medical centers, but this data resources is largely untapped because even at each single site, data are on different systems. They cannot easily be joined, and even if you would manage to join on all this data at a single site, it is very difficult to do analysis across sites. And so there's this big funding scheme of the Medical Informatics Initiative, where consortia of German medical centers, university medical centers are funded to build so-called data integration centers at each university medical center, and then build infrastructure for joint analysis across the different sites. MIRACUM is one of these consortia. And this map of Germany shows you the sites of the MIRACUM consortium. And so we are, after about 4 years of funding, we are now in the position where our data integration centers locally have integrated many relevant data sources. And we are in the progress of building infrastructure for doing analysis across sites. And as you may have guessed, this means that we did roll out DataSHIELD installations across all MIRACUM sites that allow us to do these analyses. And one important background, this was actually our only option, is that in contrast to other countries, we are in a legal situation where we don't have a typically consent of patients to use their routine data. And legal constraints mean that we are allowed to do analysis of routine data at each single site, like also for researchers, but not across sites, or even researchers from other sites are not allowed to use our routine data. But what we are allowed to say, okay, we can do analysis of routine data, for example, in Freiburg, and we can publish a paper on it that has mean values and correlations and stuff in it. And then we can say, wait a moment, if we are allowed to send mean values and correlations and things to a journal for publication, we also can send this to a DataSHIELD client. And luckily, the data protection officers were of the same opinion. So we could say, using DataSHIELD, we are using aggregated statistics that we have been using all along for doing publications on routine data at the single sites, and suddenly we can do analysis across sites. So this is much about the technical background, but before telling you more about what we have been doing, let's take a step back and look at what actually our users need. And what I did there, I took this nice picture directly from the website of the German Medical Informatics Initiative. Please ignore for the moment that this kind of enforces gender stereotypes with the male expert doctor explaining things to the female patient who attentively listens to the explanation. So we will ignore this for the moment, but look at what are actually the demands or requirements by our users. One thing, I mean, what we frequently get from doctors is this blanket statement that we want to find patterns in data, in routine data, and we want to find this across patients, because if we have a specific patient sitting together with us and we want to explain something, we want to say, yeah, for patients similar to your case, we saw this and that. And frequently we are in a situation where we don't have enough patients of a specific disease class, subclass at a specific site. And so we want to do analysis across hospitals. And this is obviously where DataSHIELD comes in. But our patients rightly demand that we need an extra layer of protection, because health data is very sensitive data. I mean, also the European unions and other legal bodies are saying this, so then extra legal level of protection is needed, even compared to, let's say, when you compare it to clinical trials or epidemiological studies, because in this routine data setting, we are in an even more sensitive situation where the patient primarily wanted care, wanted cure, and didn't primarily want that we use post-hoc the data for some analysis. And the good thing, if you think about techniques like DataSHIELD that can have some technical complexity in the setup, at least in our funding scheme now, we can say we have the data integration centers, so the technical centers that do at each site that do the integration. They have lots, or I would say a decent number of computer scientists and other staff around, and so we can manage technical complexity at the back end. But one limitation is that we cannot afford to tailor technical solutions to each individual user. So we can say we roll out DataSHIELD and then everybody has to be happy with it. We cannot say, yeah, this user gets this specific modification and that user gets this specific extension, because then our staff at the data integration centers will quickly be exhausted. And what you have to take care of, and I attached this bubble to the hand of the male stereotype expert doctor, we have limited technical expertise of our users. So when we say we cannot tailor technical solutions to the individual users, our users will typically not be technically competent enough to do this step for themselves. So we have to find a solution. And so, this is just a rough coordinate system showing the important dimensions. So we have like complexity of setup. This is what we do at the back end. Like, for example, in the data integration center, we have the flexibility of analysis. So this is how flexible can our users be in finding patterns, and the size of the circle size is how easy is this to use for the user. And I put DataSHIELD right into the middle to see where are the competitors and what are potential extensions. For example, like what we have been doing in MIRACUM to see how we can improve. And I mean, there are competitors out there. Let me see. Yes. The first competitor from the Odyssey project, where the basic idea is you don't have a complex system for sending calls out from an analysis client, but you have like standardized databases at different sites, and you basically a requesting site programs an R script and sends the R script to all the sites. The sites run this and send the results back. And this can, for example, if we did it in some instances, this can be by plain old email. And you see, this is less technically complex, but flexibility of analysis is severely limited because you don't want to send too many R scripts, so you cannot do iterative things or stuff. There are other competitors, for example, like Feature Cloud, that look a little bit easier to use with nice web interfaces and things, similarly complex in setup, despite having a kind of app store, but unfortunately are somewhat limited in terms of the analysis you can do. I mean, they have nice, maybe more machine learning approaches compared to what we tend to have or tended to have in DataSHIELD. But if you need some data pre-processing steps, then you're quickly at the limits, and without good data processing, most of you know you're quickly lost and cannot do anything at all. So what can you do? So first thing, naturally say, okay, other solutions have machine learning. We can add many machine learning approaches to DataSHIELD too, and move up a little bit in terms of the flexibility of analysis. We can also say, if we want to get even more flexible in DataSHIELD, we shouldn't be tied to R as a programming language. We can say, let's go beyond R. This will make technical setup a little bit more complex, but hugely increase flexibility. And finally, I will show this, we can work with synthetic data, adding even more complexity, but hugely increasing flexibility. You can also say, we want to make this easier to use. For example, you could say, we combine DataSHIELD with a Shiny interface. This makes it much nicer to use. But unfortunately, we're getting in this area where, as data integration centers, we say, okay, we have to support these Shiny apps and tailor these. So this makes it more complex. And so in the end of my talk, I will get to some prototypes we're experimenting with. I will say, can we do some kind of hybrid GUI that is some kind of in between? Okay, but before I get to all this, let's start with this extra layer of security that our patients demand or actually deserve. And for this, I mean, it is good to reflect that in DataSHIELD, we have this model of like, we have analysis clients that are sending out requests, and then these are directly answered. And when we talked about this to our data protection officers, we draw a nice schematic figures where, I mean, this was not the initial figure, but we have the setting, we have the hospital network, we have a firewall, and the clients are outside of this firewall. Then the data protection officer said, wait a moment, does this mean that a client from the outside can reach in to our hospital network through the firewall and directly request analysis? This is a no-go. And so we said, okay. And then we said, yeah, but we still want to use DataSHIELD, and other approaches also work that way. And so we had to come up with a solution. And what you see here is the cube mechanism that we come up. The idea is actually rather simple. You say the clients don't directly send their requests, but you have a server sitting outside of the firewall collecting these requests. And then you can have servers inside the firewall reaching out to the server that collected the request to see, okay, what is there? What do we actually want to answer? And typically, I mean, this is done automatically, and then these requests are answered from the inside, and the client gets the answers. And the reason why we have all these rectangles making this schematic look a little bit more complicated, because we had to think about how is this administrated. So for example, we need to have a GUI for these extra servers, and we had to think about how can all this be deployed. And so we have a Docker-based solution for deployment in this, because the aim was we want to easily deploy this across all MIRACUM sites and also be easily in the position to distribute updates. And so this is now installed everywhere, and our data protection officers are happy with it. And so that we're not punching holes into the firewall, and we experienced this is really nice for selling DataSHIELD and convincing people that you can use it. So maybe this is also useful for yourself. I promised some machine learning extensions, and I'm starting with one that we did quite some time ago. This is so-called component-wise boosting. In the variant we are doing, this is basically about regression models, but we are not just estimating regression models by maximum likelihood, but you can regularize these estimates. You can draw the estimates towards 0 or to exactly 0 to see, okay, you have a huge number, for example, in a regression model. Let's say you do a prognostic model in a medical setting, and you have a long list of candidates of potential prognostic factors, and regularized regression can draw the estimates of these of many of these to 0. This means, okay, these are not so important for prognosis. And then you arrive at a prognostic signature of the prognostic factors that get non-zero estimates. And one approach to get such regularized regression models is by component-wise boosting. And we developed this and deployed this with DataSHIELD. And the thing is, I mean, if you do standard maximum likelihood with regression models, for example, generalized linear models, typically after 3 to 4 iterations, so this would be 3 to 4 calls from the DataSHIELD clients, you have kind of convergence, or you can do stopping of the estimation and get reasonable estimates. You can imagine if you have a huge number of candidates, you have thousands, maybe, for example, an omics setting, thousands of potential predictors, you typically won't be able to do this with 3 or 4 calls. And so we try to come up with something. First, we had to rewrite component-wise boosting that it can be used in a distributed computing setting. And we had to come up with heuristic approaches for limiting the number of calls. And you see here an artificial application example where we had 2,500 potential predictors. So this would be nicely correspond to some settings like when you have gene expression data or other omics data. And what you see here across many runs, like the typical number of summary statistics that are requested by the client, in that case it's covariances, and the typical number of calls on the y-axis. And you can see there's kind of a trade-off. If you want to say you want a small number of summary statistics, in that case covariances that are requested are relatively small, you have to pay a price of many calls. And you, for example, you see with starting with 2,500 candidates, if you go from the bottom left, the stars up, and then you see, we start with a model that includes, that has 15 non-zero estimates of prognostic factors, the 30, 40, and so on. And you see, you can get a model with a prognostic signature with about 40 prognostic factors with non-zero effect estimates, with about 2,000 covariance summary statistics requested, but you have about 50 data calls. You can use a different heuristic. For example, you say it's important not to have so many calls to limit network traffic, but you are willing to do with a larger number of summary statistics, maybe messing up the logs of what you requested a bit. And there you can say, okay, If you do model with 50 non-zero estimates, you can do with just 6 calls. So you're close to what you are used for from standard generalized linear models, but you are requesting about 5,000 then covariance. So there are trade-offs. That means if you do machine learning with such huge number of potential influential factors, you have to be very careful how you want to optimize for the number of data calls or for the number of summary statistics you're actually requesting. I promised I'd also talk about interfacing to other languages, and this is what I will also need for introducing even fancier machine learning techniques. And the thing is, there are machine learning techniques available in R, and you can, as we showed with the component-wise boosting, you can rewrite and re-implement these for DataSHIELD, but there are limits in R because often, I mean, you try to avoid loops, for example, in R, because these are slow if you program algorithms with loops, but you cannot always avoid this. There are a whole class of techniques, for example, like more advanced approaches for artificial neural networks where you cannot avoid this. And then data science community has decided that these things are done in Python, or we tend to use Julia as a language for that. This isn't done in R, or it's severely limiting. So we said there are already interfaces out from R to other languages, and we want to use this. And because we found that with Julia as a machine learning environment that we want to use, the available interfaces didn't quite do what we wanted, we did our own. It's called Julia Connector, and you see some of the criteria compared to the other approaches that were already out there. And you see there are issues like communication, then between DataSHIELD server and Julia, where you say, okay, what kind of communication interface do you have? What performance issues do you have there? Is information lost? And also, how flexible is this in really getting access to all the libraries? How difficult is it to write wrappers, for example, around the Julia libraries? Our approach can do this automatically, so we don't have to do much wrapper writing. Is it interruptible? So in case there are connection issues. And so we try to get a yes here, so ticked off in every important aspect that we needed for integrating this into DataSHIELD. And this, for example, allowed us to do the DS Boltzmann machines package, which is a very thin wrapper around our package Boltzmann machines. And that is a very specific deep learning or artificial neural network approach. And because we had this Julia connector, it was actually quite easy to do this wrapper and to say, we have a Julia package, and see now we have a DataSHIELD package for this. And I'll get to what we do with these deep Boltzmann machines or deep generative models. I'll get to this within a minute. But first, I'd like to move to one further extension topic, and this is synthetic data. So I said now we have extensions for DataSHIELD, for machine learning, for linking out to other languages, but we want still more flexibility. And there is now this whole community saying, as an alternative to a federated computing approaches, it could be a reasonable approach to take your original data, train some statistical approach on your original data, and then use this trained model to generate synthetic data. So these statistical models that can do are typically called generative models. And before you saw already, we were talking now about deep generative models. So for example, deep Boltzmann machines I showed you can do such a thing. You can put in original data, train the model, and then generate synthetic data for it. I mean, there are some problems still. You don't know really yet whether these in what corner cases the synthetic data can still reveal some information, but at least there's a growing community working on this. So we were thinking about, can we or could we combine this with DataSHIELD so that our users have another option within DataSHIELD? And I mean, I already spoiled the surprise a bit. We will get to deep generative models, so using neural networks for doing this synthetic data generation. But at first, we wanted to look at a much more simpler approach. So we did this here in our 2019 paper, and the idea is that you can already get pretty far with synthetic data generation when you only have very simple summary statistics. Specifically, you need a correlation matrix, and you need for each individual variable, you need moments, ideally higher order moments. And we said, wait a moment, this we can already do in DataSHIELD. And so we devised an approach. You see the rough algorithm in the top, where we say, as an input, we have marginal moments of the individual participants or individual patient data. And we have, for each pair of variables, we have correlations. And these are our key IPD summaries that we have there. And we have a copular-based approach that can generate fit a model, generates synthetic database this, and then you can do your analysis on this synthetic data set. And if you do want to do this several times, you can average across several synthetic data sets. And I said, okay, we got the summary statistics that we needed from DataSHIELD. I mean, with mean values and correlations, it's obvious DataSHIELD can do this. But we also needed skewness and kurtosis. And when we looked at that time, we didn't get this directly. And so in that paper, we also describe a formula for getting approximations that work quite well. This means that even if you want to do this yourself, that even in 2019, you would have been able to do this. And so this means you can do this basically today. If you say, if you have a DataSHIELD client, we have original data sitting somewhere in a DataSHIELD setup, you can already request summary statistics and construct synthetic data based on these summary statistics. And this also limits the privacy protection concern, because you're not requesting more than you would typically request in a DataSHIELD session. You're only requesting correlations and marginal moments. And you can have synthetic data. And I'll get in a moment to why this could be nice. And we took specific care because, like in a medical setting or as statisticians, we are careful to say, okay, we don't want to have just any synthetic data. We want to have realistic synthetic data. And this means also, for example, things like distribution, skewness should be okay. And you see here an example where we had data from 4 centers, and you can see the original data, the distribution in blue, and you can see our reconstruction in green, and you see we get the skewness, but then, for example, in EU South, there is this bimodality. Unfortunately, we don't get this, but we have a more recent approach that can also do the bimodality. Also simply based on what we have already available in DataSHIELD. So this you can already do. Which makes it more difficult to say, okay, now we need to get even more fancy, but we can't get even more fancy. And this is when you say you don't trust just correlation matrices and marginal moments. will give you all the patterns, all the important patterns that had been there in the original data. And this is where deep generative models come in. So I told you before that we, using our Julia connector, we could do our DS Boltzmann machines package, which again wraps our Boltzmann machines package Julia, which can fit so-called deep Boltzmann machines that are a kind of artificial neural network approach that's generative. So you don't just learn some transformation of your data, but you learn the statistical distribution of the data, also with potentially very complex patterns, and you can then sample from this statistical distribution. And so the schematic here, what you can see in the left-hand side, so this is the typical DataSHIELD approach. So you are requesting some summary statistic, F in that case, you send it out to the different clinics. And the summary statistic is calculated based on the original data, and then the result is sent back. And then this can be iterated. For example, if you have an iterative algorithms like generalized linear models, and then you get your model fit. And the alternative now is to say, wait a moment, we can not only do synthetic data now, but we can do this at different sites. So the researcher says, I want to have synthetic data, sends this request to the different sites, and the sites now a generative deep model, for example, like a deep Boltzmann machine, is applied to learn the statistical distribution from the original data. After having learned at each site the statistical distribution, synthetic data are generated, and then these synthetic data are sent back. And then you can do any kind of analysis with these data sets. And the question is now, how well does this work? So I've here an example where we see in panel A, so top left, some data set, artificial data set, 250 500 observations with kind of a block structure. So there are correlated variables. In panel B, you see what our Boltzmann machine makes out of this if you train it and get synthetic data just on this joint data set. And you see the block structure is kind of recovered. This also is the case if we split the data into two parts, like as you would have it if you had two clinics. This is the bottom left panel C. We see the block structure is still recovered, and then we said, okay, this to the extreme, let's split the data set into 20 centers. So this means each center had only 25 observations. So this means we had to train an artificial neural network with just 25 observations, which kind of seems impossible. But luckily, the Boltzmann machines have pretty decent performance with small sample sizes, as we also saw in other contexts. And so each site, just based on 25 observations, trained the deep Boltzmann machines, did generate synthetic data, sent this back, and then we paste it back again, plot it again, and you see, okay, the block structure no longer is as clear as we would wish like, but there's still pretty much left. So, and this is actually really an extreme case with just 25 observations per case. So we are pretty confident that this is a reasonable approach. And why we're going through all this, first with the simple synthetic data approach, and also now with the deep generative approaches, because I always we want flexibility, and I guess in the discussion before the session, Becca also said something like our users are used to Excel and things, and the question is, can we do analysis in Excel in a federated computing setting. If you do it with synthetic data, you can do this. I mean, this is an example. We actually did this, just a fun exercise with some data sets where we said we had original data, did synthetic data, and just for this presentation loaded up. It isn't Excel, I think it's Apple numbers or something, but it's equivalent. We loaded it up and you see you get this fancy interfaces where you can do 3D plots. As statisticians, I don't like these fancy 3D plots, but basically our users like this, and then we can, with synthetic data, we can give them this flexibility. But it's the synthetic data approach, and we were also thinking, can we give so much flexibility if we stay in the non-synthetic data, in the classical federated computing setting? And this is where I already told you we are looking at this hybrid GUI approach, which is still quite experimental. So this isn't finished yet, but this helps us thinking and what can actually be done to get like federated computing maybe as easy, or at least on a trajectory towards as easy as Excel. And this is where Daniella Zoeller, so basically who is my co-presenter for this keynote, comes in, because now it's demo time. I know in keynotes you never should do live demos because they always go wrong. Maybe today we can get an exception to always, and let's try this time with demo time. Okay, I'll try to close my...
I think I already took over the screen sharing. So
yeah, Daniella's now got the screen
perfect,
sharing.
Perfect.
Yeah.
So this
We're on
part
track.
of the day already. So I'll hand over to you, Daniella.
Yeah, thank you very much. So basically, Harald also gave over the responsibility if the demo is not working to me. So it's not his officially fault then in the keynote. So what you see here is a so-called Pluto notebook. It's in the language Harald already told you about, the Julia language. Maybe you have heard already about Jupyter notebooks. This is something similar. So these are so-called scientific notebooks where you can combine description with code and make it interactive so that it's rerun, and in contrast to this markdown setting where you have a fixed result, here you can redo it. I've already started it, but setting it up takes a few moments. We can just go through it here directly. So you see here, we have here this internal setup. Behind it, we have some Julia code. I do not go into the detail here, but just you can click on this little eye to show it or to not show it. Here, this is already run. Here we have the part where we establish our connections to the Opal servers. In the background, I'm running the, oh, sorry. I typed in the letter. I'm running the virtual machines of DataSHIELD. So we have two studies, but as you can see, I'm already connected here to my 3 servers, so 3 instead of 2. This is because we have here also the server that is run by the Opal demo included. And maybe I would now want to say, no, I do not want to have it in. Then I can just say I want it to be disabled. I have to reconnect them. This takes a moment. You can see that now all the fields and also the fields below are run. This is this little bar here, and now you can see we are connected to 2 servers. I have a config file where the connection, so the server name, the URL, the tables, and my user and my password are stored in. I can now save it so that the next time I would open up my notebook, already the server 1 is disabled and I'm only working with 2 servers, so with the 2 virtual machines of DataSHIELD in this case. In the next part here, we have which variables we want to use. We have here all the variables that are available at the site. We can unclick them. Then again, it is run, but we can also say here, just select all, and then every variable we have is included. Everything I do now results in the rerunning of it. So this is why some errors show up below here, but just don't care. If I rerun it, they just disappear. I can here, as we have made some descriptions later on that depend on whether the variable is a continuous variable or a categorical one. We also have something where we want to check whether in which category it falls. And we are running here in the background. If you say re-import continuous variables, we are just running on the data dictionaries that are available on the OATPULSE servers, and we are just looking for the ones which are numeric and say these are our continuous variables. But by opening up this manual selection button here, all the variables are shown, and I can check whether this automatic import of continuous variable worked as I wanted them, or if I have another one which was just missed.
Sorry, Daniela, can I interrupt? Is it possible to make the text a bit bigger so that people can see easier? Are you able to zoom in?
I'm trying.
Yeah, that's
better.
Yes, that's much better.
Okay.
Thank you.
Okay. Okay, now we are going to the analysis. You can see that we have here this dependent variable. So in this case here, these are only univariable analysis. So dependent variable is maybe not the right word, but it's because it's slower that it's going on again. And here I can click on the variables. You can see here I have the BME categorical. So we are getting the summary. We just get the counts in for the different factors. And I can go through it to study 1 and study 2, all the results the DS summary function is giving me. When I now click here on continuous, it again re-evaluates what is going on in the background. Then the error pops up shortly. I just have to rerun it with this play button. And now you can see that I got a numeric variable and I got the quantiles and the means. And again, for study 1 and study 2. Now I come in why I've called this dependent variable. Here, below it, I have called it independent variable. Now we have a continuous variable that we want to see in groups, and we are using the mean GP function, and we can get for the study 1, study 2 combined the mean values for the different categories of BMI, also the number of subjects, and the standard deviation, of course. And if I now switch here to another categorical variable, it's again rerun. I expect that also the method error is showing up shortly, but it's going back directly. And you can see that now we have got here a contingency table. Oh, I've now, of course, I've put the same variable twice, which is not so informative. So now we have here the BMI versus the gender, and we can go here through all of the results of the functions, so the combined results and also the study specific values. So the call props, counts, and row props can be gone through. Now I move over to the generalized linear model. So you can state here how many variables you want to have in your model. So this is the easy version. Again, we have here this dependent variable. And here now, if I add, for example, a second variable, you get another option. And here you can also state if you just want the complete factor, or if you also want the interactions with the with this sign. You get here is shown how this translates into the formula for you to check. As this is the dependent variable is a categorical variable, we are using the binomial link. We are automatically include the standard link. So this is now running the logistic regression. And as a default, we get to see here our coefficient matrix, so the estimates and the p-value, including the odds ratio and the confidence intervals for the odds ratio. And we can also look into the disclosure risk, for example, or the error messages. So everything the function is giving out, you can just go through here, and then you can see this is running really fast. So here, this is just loaded in the background, and it doesn't need to be rerun. I can also go here to the continuous variable. Then I need to, sorry, where am I? Here. Then I need to switch the family to Gaussian, and you can see that now the link is identity, because now we are running a linear regression and we get the same results here. And if you are a more advanced user, you can also switch to the advanced mode and add here your own formula description completely. And this is also for the advanced family link suggestion. So here you can see that now in the family we have way more options, but this is really, you need to be an advanced user for that. And also you can, as I said, this is a scientific notebook where you can do a lot of your things you want to do. And you can just add a new cell with this plus, and then you can just, oh, sorry, I copy pasted something other. I want you to do a box plot with our D variables. Just let's take, I think lab HDL, and then data sources equals connections. And now if I run it with a with this play button, you can see that I now get this box plot also. So here I can add really anything I like, as I would. Recording totally stopped. So this is what I can do here, very flexible. And with that, my demo is over, and I'm going back to the presentation of Harald. Oh no, I cannot see the start buttons behind. And so Harald, back to you.
Great, thank you. So, and I'm just briefly finishing up. I mean, so I think we have quite some developments we did in MIRACUM, but luckily work never ends. So there's always more interesting things to do. And the first question, so if we give our patient the first speech bubble is, I mean, big question is so that we had in the synthetic data, but also in the federated setting, can we actually quantify the protection level? I think this question is keeping the whole community actually busy. And one approach was, we can say, yeah, maybe we cannot exactly quantify, or the quantification is not satisfying, but we could, for example, look at log files. Recently, I talked to Becca, and the DataSHIELD group is already, I think, looking into this. But this is also why we were basically, for example, like in the component-wise boosting setting, very careful, like to say, okay, we don't like flood the logs with requests. So we also, with all this machine learning stuff, you have to be careful to do things where you get a reasonable log, so that if you want to look at it, if you want to automatically analyze it, this is still feasible. And the second set of challenges, I didn't talk much about this, is we need to harmonize data. So if we don't have harmonized data at the different sites, we have nothing to put into our Opal server. And in our experience, this can be quite challenging. I mean, in the medical informatics initiatives, there's now a standard data model that everybody uses and currently fills. So this will be feasible, but this has, to be honest, this has been really much work, and this has a multi-year process. And the question is, how can we get better and maybe even reap the benefits of others have done it? I mean, for example, I have cast the Odyssey project initiative as a competitor, but you could say, okay, what have others, for example, done? Like, for example, in Odyssey or Primer OMOP, they have developed a common data model. And so it could be an approach if you say something like, let's take the data models others have developed in other contexts, like, for example, OMOP Odyssey, and combine this with DataSHIELD. And as I said, in the medical informatics initiative, we had our own solution, but now we are looking at moving beyond the standard medical informatics initiative core data set. And so this is something we will be looking at. And finally, this is my last hopeful slide, because I think the good thing about DataSHIELD, really, it is here today, it works now. would have worked even without all the extensions we made, but I hope even better with our extensions. And as a result of this, we were quite successful, or are in the process of being quite successful, of also convincing the other medical informatics initiative consortia that DataSHIELD could at least be something that is available everywhere, even if it cannot do everything maybe other systems could potentially do in the system. It is something that is here today, with the extensions can cover most of the use cases. And so we are rather confident that soon we will have DataSHIELD maybe rolled out across all university medical centers in Germany, which I think would be quite some success. And with that, I mean, success comes with lots of hard work from many people. First, I want to thank Daniella for doing the nice demo, which worked perfectly. So we contradicted the common claim, but I also want to thank the whole MIRACUM group for all the hard work that was put in. And also in particular, I want to thank the DataSHIELD team for the great support, without which we couldn't have been successful in MIRACUM and the Medical Informatics Initiative. Great, this is it, and I'm looking forward to your questions.
Thank you, Harald, and thank you, Daniella. That was really, really magnificent. Lots to think about there. It certainly got me thinking about some of the issues that we discussed yesterday in relation to multiple imputation, and whether there might be some ways of tackling those problems as well, perhaps with using the synthetic data. But I can see that people are starting to ask questions. Please do raise your hand if you have a question to ask. And the first question is going to come from Becca.
Hi, Harald, thank you. That was really fascinating. I've got loads of questions. I will start with one, which was related to some comments that were said by others yesterday. And I was just interested to know, how long did it take to get the agreements from the hospitals, from each of the sites, to agree to use DataSHIELD, and whether or not you had any, I guess, tips for or recommendations of how to approach that, because that is something that I think a few groups are struggling with.
I mean, as soon as we knew how to approach this, it was rather quick. So like our initial mistake was, like, we produced this long documents describing the DataSHIELD infrastructure. And then when we finally realized that we needed this one diagram that easily in one diagram explains the whole idea and how DataSHIELD is even more protection compared to other approaches, we had our data protection officer quickly convinced. And then my impression was, if you manage to convince one data protection officer, it's much easier to go to the next data protection office and say, okay, he already agreed, let's talk. This is our diagram. This is how DataSHIELD really protects the data compared to alternative approaches. And so this is, I think, after we knew that we had to take this approach, it was actually rather quick.
Okay, thank you.
I'm going to
recommend this one simple diagram.
There are quite a number of questions coming in now, so I'm going to pass the next question is to Steph Van Buren, and then it will be Paul, and then Arthur.
Okay, thank you. This is very impressive work, and I'm really thinking about lots of ideas. One dream application that I have in mind is that if the doctor consults with a patient, then the doctor will be able to show how other patients in a similar situations would develop. So you would, given the characteristics of the patient, search all the databases in Europe, and then present those cases that match the case, and then see, well, if you do this, then this happens to this 25 patients, and if you do something else, then this happens. Now that's difficult to do with current privacy laws, because we cannot simply take out personal profiles, because these are protected. But I have a question for Harald. If you are able to fit the Boltzmann these Boltzmann models on the distributed data sets, would it be possible to create sensible matches for an individual patient and show that to the patient. That would be really cool if that would be possible.
Sure. So basically, as soon as you have the synthetic data, you can basically run any algorithm on it. I mean, what we already have done is you look at the similarity. You have your patient. You say, this is the synthetic data set. Which are the patients that are most similar to your patient? And then you can show these synthetic patients to the patient. So
that's really cool. Yes, yeah. That's really cool. Yes, thank you.
Paul?
Great. Yeah, thanks. Okay, great. So first of all, that was a really excellent presentation, and it's fantastic body of work that you've done. So thank you very much. So got 2 points. One, so as you know, we've discussed with your team, Daniella, that we're really keen to work with you on the disclosure issues. There's a whole range of things which you flagged a couple of up in your final slide. So we're really, really keen to work with you on that. So that's really good. The second thing is an issue about synthetic data. So basically, I love the idea of crediting synthetic data, and it's something that we've talked about, and there's a variety of routes we could potentially use it for in DataSHIELD. But there are 4 potential uses of DataSHIELD, of synthetic data that I'm aware of. So basically, you can use it, if you've got synthetic data, you can try out new methodology and see, so you can learn to make sure you can analyze it, right, for groups that are not used to doing analysis of a particular sort. Secondly, you can use it, as you identified, for training some sort of machine learning system. So it's great for that. Third one is you could use it for some sort of output from DataSHIELD that doesn't have to be exact. And here I'm talking about graphical output, for example. If you want a good output that looks sensible and covers the bulk of the information, then it can be used to drive that. But the one that I'm not sure whether you're proposing or not is the one that bothers me, which is that, do you think that there are some instances where basically you can use it to do real data analysis? So instead of doing, I mean, when you're trying to get exact answers, are you proposing it as a way of replacing real data analysis? And the reason that concerns me is obviously that you have to swap then the constraints of governance by the constraints of limited inference. So sorry, that was a long way of asking the question.
Yeah, so my answer would be, so this 4th thing, like replacing the real analysis, if one can avoid this, I would suggest to avoid it. But if the alternative is no analysis versus analysis on synthetic data, I would say let's go for the synthetic data. And I mean, it's a similar thing if you say, like, if you have constraints like in your cross table, you are not able to show cells with less than 5 entries or something like that. When you're in a similar situation where we say, okay, there is not the option to show the real cross table. Yeah. And so it's no cross table, or the cross table where you lose the cells with less than 5 entries, and then I say, okay, it's still better than no cross table. And so my suggestion would be try to avoid it as much as possible. But if the alternative is doing nothing, then I would even recommend using the synthetic data for real data analysis.
Okay, thanks. That's a really nice answer. Thanks.
And also we are thinking about if we can use synthetic data to inform steps that are part of the, so for example, modeling steps, deciding which model you want to use, and then just run it on the data basically, instead of having to look at which interactions do you want to use, which transformation you want to use. And for that, you could also use the synthetic data. Or we think that this might be also an approach we could go for.
Brilliant, thanks.
Okay, so now Arthur.
Okay.
Unmuted.
Hi, thank you. So impressive, and I think that having that many deployments of DataSHIELD is also pretty impressive. This is, well, I'm asking a few questions because we have to overcome them during recap, and I will talk about it in a bit. But for example, did you have problems with data protection impact assessments and stuff like that? Because once you go down that path, you will have lawyers asking which is the data. And of course, given that you are with DataSHIELD and it's a kind of a meta approach, you could have anything there. So did you go for a subset of variables to convince them that it's all right? Because ultimately you could share someone's address because it's a valid field like anyone else, not like anything else. So I'm just putting these questions because they tend to come up. Then these are questions, and I could go into more detail. Sharing your diagram is probably helpful to all of us if it's something, because one of the problems is also the barrier of communication.
Yes.
And if there is something that works, I think we all should be interested in it. And another more common question is, there is someone also at Inesh Tech working in the, well, shiny and not only shiny interfaces for DataSHIELD. Maybe I could introduce you, and then you can help each other, because this is an effort still ongoing on our side.
Yeah. Great, thank you. That's a great idea. So, but first to the impact assessment. I mean, what was useful for us, because we have this definition of this core data set of the Medical Informatics Initiative. And so if you do the impact assessment, we can say, this is the core data set, which actually is quite large. So the list of variables is quite long. But basically,
as long as you have a list, but you do have a list, so that's good.
We have a list. So I mean, and this is also why you say, okay, why it's attractive to, like, in the future look at the Odyssey common data model and things, because then you can point to a list, and even if it's long, you can say, okay, the address isn't in there. And so this was very helpful. This was very helpful in the discussions for getting the things through. For the GUI, for the user interface, I mean, I personally like shiny apps. One challenge I have seen is when we present such a thing to our clinical audience, they nearly immediately raise their hand and say, we want one too. And then after the second and third hand raises, I think, okay, who will do this? And so this is kind of the challenging, where I say, I personally like this, but I have this, okay, how do I deal with the limited resources? And this is why we did this prototype in exploring, could we come up with something that we say, it still looks kind of nice, still is kind of handleable, but we can do it with limited resources. And I don't think we have the final solution yet. So I like the idea to do joint discussions. So like, what could we offer that is nice to use, looks nice, but can be done with limited resources? Because this is one of the challenges ahead.
True, and I think we, from what I've seen, this is not a work that I have been leading. It's another colleague. I think they followed the same approach of dependent versus independent variables, and then of course select the dependent and the independent ones, and then pinpoint which is the operation that you are going to do. I think we have pretty much in
the common language. Maybe I can add also something to the first question you have. What is for our impact is what you have. I mean, we have this in MIRACUM. We also agreed on a technology where the data are stored in the data warehouse houses, and the site that is responsible for the research question prepares this SQL script, which takes out the data out of this data warehouse, transforms it into the analysis data set, and uploads it to Opal. And we share that. So basically they can look at that, and if the when the data are uploaded to Opal, they manually have to look at the data set and assign the one who is responsible for the analysis. So giving the rights to do the analysis is not automated. This is handled manually, because then the person who is responsible for the data has the full control to see, okay, this is what we agreed should be in Opal. Is it really only that, or did they snuggle something in? And this helped us to also convince the local data protection offices that not something is coming out from another side and requesting something they are not have not agreed to do so.
Okay, this is a great discussion. We can carry on in a minute in the breakout rooms, but first of all, we have one last question that's coming from Yannick before the break. So Yannick.
Yeah, thank you. It's more a comment than a question. So thank you for this great presentation. It's a real pleasure to see people pushing the DataSHIELD infrastructure at its limits. And I have good news for you. Since last year, there was a new concept that was added to DataSHIELD. It's resources. And the resources unlocks the kind of data that you can integrate with DataSHIELD and the kind of analysis tools you can use. So I'm fairly confident that you can integrate directly OMOP databases, for instance, and use whatever you want as analysis tools, so it can be Julia, Python, or anything else. So it will be one topic of my presentation this afternoon, if you want to see.
This is great. This is great. I mean, in particular with OMOP, because you really can build on things that other groups have already been building through the years. And I think DataSHIELD can hugely benefit from this. So this is really great news. Thank you.
Brilliant. Well, thank you everybody for a fantastic session and some great discussion. As I mentioned, there are breakout rooms that are open now, so please do feel free to join them. We'll be meeting back slightly shorter break because we overran a little bit for the discussion, but we'll be meeting back in about 20 minutes in the main session when Arta is going to give us a presentation about the Coral deployment of DataSHIELD, how that has been used in the RECAP preterm consortium and can be used elsewhere as well. And then there will be a number of lightning talks and then a report about the DataSHIELD advisory board. So look forward to seeing you all shortly and have a nice break.
When I opened the rooms, everyone got moved automatically into the room they were in before the talk started. Sorry. I was going to say that there's a couple of notices, which is that I think over the break, Alex is going to do just a quick Menti thing, just one question to get some feedback from people. So they can answer that at any point over the break. And then the second thing is that we will be observing a 2-minute silence in the UK at 11 o'clock. And so we will be in remembrance of everyone that has been lost in conflict in the Commonwealth. And so we will be back at 11:02 after the break. Thanks.
I'll just put up my slide now. It's as you saw on Menti yesterday. There will be a link which I'll put in chat, but also there'll be a code that you can go to menti.com and put in. So I'll share that now.
I was wondering whether someone could pop into the, there is one breakout room that's got a few people in it, and just copy and paste the Menti details there for them. Is that possible?
It's probably good if I don't leave being the host.
Maybe Stuart or Dimitri.
I can't go. Yeah, I can't go there.
Because if you paste it in the chat in the room, they'll see it.